we have here a plant. You have the stem, you have the roots, and then I give you like a microscopic, larger drawing of what happens on these little hairs that are on the roots. These are hairs on the roots that are magnified. That is a root hair. Then I've got, this is the stem, and the stem can be, yes, a microscopic kind of drawing of what it looks like if you put it under a microscope. And this is a cross-section of a leaf. If you take this leaf and you cut it in half and you put it under a microscope, it will look like this. Okay? Now, for this plant to survive, it needs different forces to operate. One is, it needs osmosis must take place here. That is, the water must go through a membrane into the root hair. And then from there, it will have to go into the xylem and then up the xylem with the mineral salts to the leaves so that it can produce the food. So that's the first, if I can put it on the first force, is osmosis. And osmosis is the following. It is from a high concentration of water that's in the soil to a low concentration of water that's in the root hair. And then it moves from a high concentration to a low concentration. Low concentration means there isn't water in there, or there's not enough water in there, and a high concentration, it means a lot of water. So water will move from a high concentration to a low concentration through a medium, through a membrane. That's osmosis. Okay? Now there's another, so you've got that particular force now. The movement of water molecules from a high concentration to a low concentration through a membrane is osmosis. There's another kind of force which is called diffusion. Diffusion is what we experience with no barrier in between. No barrier in between. If somebody sprays underarm, there's a high concentration of the spray, and then later on you will smell it at the back. There's a low concentration there. It's diffusion. It has diffused, moved from a high concentration without a membrane into the other parts of the place. That's diffusion. That's that force of diffusion. Now that you'll see will happen up here. Diffusion. Right? Now, after the water arrives in the xylem, some of you are not looking, it will have to climb up this tube here to the top of the plant. And it will climb up because of what we call capillary forces. Capillary forces is the force of water or of any particular liquid being sucked up and pushed into a thin particular tube. And the reason why it can do that is because of adhesive forces that operate. Adhesive forces means the force between two different kinds of molecules. There's the molecules of the xylem tube and the molecule of the water. So the molecule of the water, this is the side of the tube, and this is the water climbing up. So the adhesive forces here is stronger than the cohesive forces. Cohesive forces means forces between molecules of the same kind. And adhesive forces means molecules of different kinds. Now in this case here, the adhesive forces are stronger than the cohesive forces. And that's why it pulls the water up. Because the cohesive forces are stronger than the adhesive forces. So now the molecule can climb up this particular tube. But if the adhesive forces were stronger, the cohesive forces were stronger than the adhesive forces, then the water will not move up because it's keeping itself together fast, stronger than what it will pull up on the other side. So we need cohesive forces, capillary forces to bring that water up from the ground into the leaves. It needs the water and it needs the mineral salts up there, which is dissolved in the water, so that the plant can start making its own food in the plant factory, which is the leaf. Okay. Now, this is going to be a long video, but I have to do it all together. As the water comes up here, right, it sucks the water up every time from here into the root, but it can only do that because there is a gap that is created every time in the tubes. The gap that's created is that the water comes off here. The water gets pushed out under the leaf, which is called transpiration. And why does the water go out by the leaf? Because the water is high concentration of water inside the leaf, low concentration of water in the air. And so the water wants to move and move out of the leaf to go into the air. And then it creates a gap. Every time it moves out, molecules move up, then it makes a space for other molecules to come in through the roots. And so you have that cycle happening. Are you with me? Because a vacuum effect has been created. Whenever you pull something, because the water around the leaf is less, the water from the leaf is more, it slips out and it moves into a higher space. It's like if a room gets full, people want to walk outside to go on the stoop because it's too full. High concentration of people, low concentration outside, so you move out and find a space for yourself. Same molecules do exactly the same. If there's a lot of the same molecules in a place, it's a high concentration, and there's less on the other side, it will move out. And so it creates a vacuum. The moment it creates a vacuum, other molecules will fill in. And so you have the vacuum effect. If there wasn't a vacuum effect, we will have a problem. This is one of the major forces in life, a vacuum effect. Because it creates, if we sweat, water comes out of us, then the body pulls water out of the food to replace it and keeps us looking the same. Because the pressure then is the same. Air pressure, very important. The air pressure is being kept constant here. When the air molecules move up, another water molecule changes phase and goes into the next phase from water to a gas. Because transpiration is water changing from a liquid to a gas through heat, extra heat from the sun. It then heats up the leaf, and the water at the top of the leaf or at the bottom of the leaf here, where the stomata is, it evaporates, it moves out, and it creates a vacuum, an effect. Now, how does a vacuum effect work? You know, when you have a syringe, if you pull up the top of the syringe, you pull air out. You make air, you make a space for air. So as you pull, you make space, and then the liquid comes into the needle to fill up that space. And that's how you can pull liquid out of a bottle and fill a syringe to give an injection. This injection needle, as they call it, a syringe, is fully, as I say, vacuum packed. You pull, create an airspace, the liquid comes in. If there's something wrong with the syringe and an air bubble comes in here and somebody injects you with an air bubble in there, that person will die. An air bubble in your bloodstream will cause death. Because an air bubble will go through and come to the heart, and then there's air and not blood. And it will just break whatever is in there because the air pressure builds up. So air pressure, very important. Now, all of these, adhesive forces, cohesive forces, air pressure, vacuum effect, transpiration, diffusion, osmosis, they all work together, those forces. But they can't work together if you don't have gravity. Gravity is the thing that keeps the plant in the ground. If there's no gravity, the plant will just go. Nothing happening. There's no gravity, no stability of the plant. So gravity also plays an important part here. If you have the water molecules and the mineral salts and the carbon dioxide mixing together to make your carbohydrates, it can only happen because of intermolecular forces. when molecules start connecting with each other. They can connect with each other because they have attraction forces between each other. So you can also talk about attraction forces. Attraction forces. I'm going more than what I normally do. Attraction forces. Between plus and minus, they attract each other. Between the North Pole and the South Pole in the magnetism. Also opposite forces that allow this thing to happen. Attraction forces. So that molecules can connect and atoms can connect. So they're intermolecular forces. And intermolecular forces is forces between molecules. Then you get nuclear forces. And you get atomic forces. That is in atomic forces. And that is between the atom and the electrons. And the electrons and the protons. That intermolecular forces. All operating all together. We need air pressure. But interstellar forces is the force between the sun and the moon, and the sun and the earth, and the sun and the galaxies and the stars. Those are interstellar forces. All keeping a balance, as Allah says in the Quran. Allah has created a balance in this universe. And Allah says, you cannot disturb it. We are not able to disturb the balance of nature. If there's one thing happens, Allah will put something else in place. If you watch the sky, you'll see as the clouds move up, there will be other clouds that fill up the place. And that constant cycle, that's how cycles are created, through different forces. Now, I don't think there is one lesson on internet that covers all the particular forces together. You'll have one particular 3 forces, etc. together. I saw now a website there, 3-4 forces. But to explain all of them together, I don't think it has been done, I'm not sure. But I don't think they all teach, because this is physics and life science together. Remember yesterday's topic that we had? They separated everything into different particular compartments to make money. And they broke the unity of things. And our job is to bring things together. So here, if there isn't a high concentration of water here, and a low concentration of water there, you won't have the water moving up into the leaf. Here's a low concentration of water, vapor in the air. So the water goes out by the stomata, and then in goes the water from in the root air into the system to create a balance. To create that vacuum effect. That vacuum effect means it pulls. It pulls. What happens in a vacuum cleaner is that the motor sucks air, creates an air gap in the pipe, and then the dirt fills it. And that's how it works. The dirt falls in place where that air was sucked in, and then you can clean up nicely. And this whole system works on forces. Interstellar forces, intermolecular forces, all sorts of forces makes this whole thing happen. And then we learn about transpiration and photosynthesis, where there's a low concentration of oxygen in here, the oxygen will move in. And a high concentration of carbon dioxide will move out. If there's a low concentration of carbon dioxide, it will move in. And it will be changed, and a high concentration of oxygen will move out. Now, I hope you have found some sort of integration. Thank you.